Hello, and welcome to Agile Cheetah. I'm Frank Velazquez. I explain Agile DevOps concepts so you can successfully apply them within your team or across your organization. If you want to improve how your organization develops software, manages software systems development, or fosters organizational agility, you've come to the right place. Sounds like what you're looking for? Then please subscribe and hit the notification bell so you won't miss any future videos. In this video, I tackle a source of great confusion in Agile and Scrum circles: product backlog prioritization or ordering. It seems like a straightforward concept. Teams prioritize the most valuable or important product backlog items or features and begin work on the highest priority items. However, teams quickly discover that there is much more to prioritizing backlog items than that. The difficulty boils down to determining what is more or less valuable or important when every product backlog item addresses valid needs. How do we determine what is most valuable or more important? How do we account for dependencies and other factors that influence what we build and when? How do we do so in a consistent, non-biased way that ensures delivery of valuable solutions cost effectively and in time to be valuable? As of 2011, the Scrum Guide began defining the product backlog as an ordered list instead of a prioritized list. Why was this change, and what is the difference between prioritizing a list and ordering it? As Barry Overing states in his Scrum.org article, the focus on ordering over prioritization underscores the active role that the product owner continuously has to play in the ordering and reordering of the work in a manner that maximizes value. Simply stated, many factors influence when Scrum teams develop and release and what they do, not just what is considered most important from a business or mission perspective. Non-trivial software solutions service many sponsors, stakeholders, customers, and end users. Their interests and priorities differ from and sometimes contradict each other. It is the job of the product owner to fuse the various needs, wants, and perspectives of that solution community into one complete, coherent, and cohesive product vision. There are also project and technical realities that must be taken into account when deciding what portions of a solution to build and deliver and when. For example, environments may not be ready for use at a particular point in the project schedule. Another is key system dependencies may be missing or incomplete, thus impeding progress. The customer may add or take away project scope during the project. Business or mission circumstances, solution community needs, solution requirements, and project priorities change as the solution takes shape through iterative and incremental delivery of system capabilities. A product owner leads continuous refinement and ordering of product backlog items to align with those changes. The most optimal ordering of product backlog items is a balance between these competing factors: business or mission value, cost or size, time criticality, technical dependencies, risk reduction, or opportunity enablement. The most optimal ordering lies at the heart of where these considerations be. Let's go over each factor. Factor 1, business or mission value. How Agile defines value is different from how traditional project management defines it. A simple definition of value is whatever solution sponsors, stakeholders, customers, and end users care about or makes them happy. A feature's business or mission value is the value created by implementing the feature. Examples of value include revenue, cost savings, customer retention, prospective customers, future opportunities, and mission accomplishment. Factor 2, cost or size. More complex product backlog items tend to be more expensive since they take longer to develop and test. The relative complexity of each product backlog item is often referred to as its bigness or size. More complex items typically require more time and effort to complete, thus making them bigger. Just as there is a correlation between product backlog item complexity and size, there is also one between story size and the cost of implementing the item. While the correlation between product backlog item complexity, size, and cost is not perfect, it is good enough to support efficient ordering of a product backlog. Factor 3, time criticality. How soon solution capabilities or system dependencies are needed also influences product backlog ordering. Again, the goal of Agile is to deliver valuable capabilities cost effectively and in time to be valuable. Delivering a capability before it is needed risks spending resources on something that may never be needed. Delivering after it is needed risks delivering it too late to be valuable. Agile achieves a just-in-time balance by constraining planning, development, and release scope to fit within relatively short timeframes. Agile achieves a just-in-time balance by constraining planning, development, and release scope to fit within relatively short timeframes, and delivering the highest ordered items first. By waiting until the last responsible moment to define, develop, and release solution functionality, we avoid over-engineering solutions or losing opportunities to provide value. Factor 4, technical dependencies. Software solutions are inherently complex. As such, their technical components often rely on other components to function. For example, multiple features may require a database backend to store data and state. Product backlog ordering must take into account these dependencies as solutions grow and evolve. Factor 5, risk reduction or opportunity enablement. With software complexity comes technical and project risks and opportunities. Agile planning spreads risk management actions across the entire software development effort. For example, a team may choose to tackle riskier product backlog items earlier. Another may identify an opportunity to shorten the schedule by delivering a dependency common across multiple parts of a solution sooner. This differs from traditional project management efforts that, even when risks and opportunities are identified early, tend to accumulate risks, address them after they become issues, and miss opportunities. One way to take all 5 of these factors into account when ordering product backlogs is applying the weighted shortest job first WSJF Prioritization Model. In his book, Principles of Product Development Flow, Don Reinertsen explained the weighted shortest job first WSJF Prioritization Model. Calculation of WSJF allows us to sequence or order individual pieces of work or jobs within a backlog. WSJF equals the cost of delay divided by the job duration. In Reinertsen's more complex version of WSJF, cost of delay is the monetary opportunity cost of waiting to implement and release a feature or capability until later. For example, if a business stands to make $100,000 per month after releasing a highly requested feature, the opportunity cost of waiting 3 months to implement it is $300,000. How large the opportunity cost of waiting to implement a feature is depends greatly on the level of effort and cost associated with developing it. In Reinertsen's model, job duration is how long it would take to implement and release a feature or capability. SAFe's model substitutes job duration with job size, which is much more easily determined through agile relative size estimation techniques, such as planning poker. Relative sizing is faster to do, more intuitive, and becomes increasingly more accurate the more we practice it than estimating in hours. SAFe's formula for calculating cost of delay is the sum of business/mission value, time criticality, and risk reduction/opportunity enablement. Unlike Reinertsen's model, which uses monetary amounts to calculate cost of delay, SAFe's simplified model uses relative sizing. As in planning poker, SAFe uses a modified Fibonacci sequence as the basis for parameter values. In calculating cost of delay, value for user business value, time criticality, and risk reduction or opportunity enablement are assigned greater or smaller values relative to other jobs being ordered. For duration, size values are assigned to individual jobs. Every job is sized relative to the other jobs being ordered. We can create a simple table to track the relative values and calculate cost of delay and WSJF values. I'll now go over the rules for populating the table through an example. We have three features, A through C, that we want to order according to the 5 ordering factors discussed in this video. We use a modified Fibonacci sequence as the scale by which we estimate the sizes of all 4 features relative to each other. The WSJF table includes 4 of the 5 ordering factors: business mission value, time criticality, risk reduction opportunity enablement, and cost or size. The technical dependencies factor will be accounted for after computing the WSJF value. We populate one column at a time, starting with the smallest item in the column. The smallest item will always be a 1. Every column must include a value of 1 for one of the features. For each column, we compare every other feature to the feature with the value of 1. We calculate the cost of delay by adding together the business or mission value, time criticality, and risk reduction or opportunity enablement columns for each feature. We arrive at the WSJF for each feature by dividing their cost of delay by their job size. The WSJF order goes from largest to smallest. In other words, the feature with the highest WSJF value is the highest ranking feature in the backlog. In this case, feature C is implemented first, followed by feature B, and then feature A. The initial formulaic answer is a start to the ordering, not the final answer. After computing an initial sequence of product backlog items, we adjust that sequence to account for technical dependencies between items. WSJF sequencing is done whenever teams refine their product backlogs. Since product backlog refinement is a continual process, there will be future opportunities to apply WSJF. Aim for good enough and trust that whatever issues surface later will be taken into account during the next round of product backlog refinement. It is good practice to not let product backlogs grow too large. Consider clearing items that have ranked low in product backlog ordering for a while. They can always be reintroduced later for ordering. Avoid planning too far ahead. Doing so leads teams to create backlog items that will likely change significantly or may never be implemented. In the same vein, avoid ordering the entire product backlog. Instead, focus on the next 3 sprints or so. Ordering items that may never rise high enough in the backlog to be implemented is wasteful. Remember that product backlog ordering is an art, not a science. The key to effective product backlog prioritization is achieving an optimal balance between competing factors. Optimal does not mean perfect. The WSJF technique provides a simple way of accounting for those factors. WSJF is only a tool to help make decisions. It is not a deterministic process that renders an exact solution. Arriving at a good enough product backlog ordering depends much more on effective collaboration between product owners, development teams, and solution community stakeholders than on applying a prioritization or ordering technique. Ultimately, the quality of product backlog ordering depends on Agile's empirical inspect and adapt approach to defining and executing work. Again, if you enjoyed this video and want to see more content like this, please click on the like icon, subscribe to the channel, and click on the bell notification icon to ensure you don't miss anything. Until later, this has been Velazquez for Agile Cheetah.